Wastegate boost pressure control is very important. The exhaust turbine is gas driven. Now that means the amount of boost that the turbocharger is going to create varies with, of course, the pressure from the exhaust. Now the exhaust gets higher in pressure as RPM goes up. So the higher the engine RPM pressure, the higher the boost pressure. This has to be controlled in order to prevent an overboost, something that can damage the engine, an overboost condition. The boost has to be limited. Wastegates are very simple valves. A wastegate is essentially a device that bypasses some of the exhaust flow around the exhaust turbine, and that's to control maximum boost. The wastegate is controlled by an actuator. The diaphragm creates an upper and lower chamber inside the wastegate itself. In our image up there, the blue is one side of the diaphragm and the silver is the other. The boost pressure is what's going to act upon the diaphragm. Remember, the boost pressure is coming from the intake manifold. So there's a hose that goes to one side of the diaphragm from the manifold. This valve is held shut by a spring inside the diaphragm chamber, and that's to keep that valve shut, so we have a zero wastegate action. The spring keeps the valve shut. The boost pressure forces it open. When we look at the top there, that graphic shows us red and blue, and the red is the hot side or the exhaust side, and that's where the wastegate is working. It works on the exhaust side. It controls pressure, it prevents overboost condition, it diverts the exhaust gas away from the turbine, regulating its speed, thus regulating boost, avoiding maximum boost or overboost conditions. When we look at this actual photo of a turbocharger disassembled, we can see one of the common problems is that the carbon builds up, causing the movement of the wastegate to stick, and that door can't open. Make sure you view the scan data for wastegate section to understand exactly what's happening here.